Okay, so if the box method confuses you for continuous functions, this is a different way you can do it. Okay, so this is a different way to identify domain and range of graphs. So if you have a discrete graph, which we already talked about, we know this is discrete because you're jumping from dot to dot. So this is a discrete example. Oops, can't see it. Okay. So this is a discrete example, right? So our basics, we know we have to use Dr. XY, dx, domain, x values, range, y values. Really nice and helpful. Okay, so for our domain, we know our domain goes from left to right. So you're going to grab each dot and you want to find the x values. So this dot is at -3. This dot is at -2. This dot is at 1. This dot is at 2. And that dot is at 5. There's your domain. For your range, same process, but you want to go from low to high. So instead of left to right, you're going to find the same dots, but from bottom to top. So low, here's your bottom, -5. Your next dot would be this one, which would be at 0. 1. This one is also at 1, so you have 2 of them. So you only have to circle the one time. Then this last one is at 4. So your range from bottom to top is at -5, 0, 1, 4. Okay, ta-da! There is your domain and range for a discrete graph. Okay. Example 2. Okay. So, once again, we want to be thinking of our Dr. XY, domain X, range Y. Okay? Now, for this one, instead of boxing it, we're going to think of our nice, beautiful number lines that we also love. Okay? So, from looking at the domain, we still need to think of left and right. So, we're thinking of the x-axis. Okay? If you were to make this as straight as you could without moving your endpoints, what would your number line look like? So you would have something there and there, and you would draw your number line here. So why am I drawing this number line? This number line represents all of this. So you see how this number line goes across? It starts here and it goes all the way across to here. What were those numbers? -5 and 5. X is in the middle and everything's in between. This is a closed dot and that is also a closed dot. So there is your domain. So for your range, you do the same thing, but up and down. So if you even want to turn your graph, you can. I just want to draw a number line that would cover this entire graph. So I could see that I can start from here and I fill it in and it would stop right here. So this entire graph, if I squeeze it in, it would fit right here in the orange. So from -2 to 2. So your y is from -2 to 2. At this -2, these are closed. At the +2, it is a solid line. So solid means equal to. So your range is from -2 to 2. Example 3. Okay, so again, don't forget about your Dr. XY. So your domain is left, right. Okay, so we want to squeeze this onto the x-axis. What would that look like? Well, if I were to start squeezing it, this would be an open dot right there. And then as you see that traveling, I'm just going to fill it in. So you see this line I'm drawing, right? It's covering all of the graph. All of this graph would be able to squeeze and fit into this purple line. Now, as I keep going, what do I notice? I see an arrow. Well, that means there would be an arrow there, and then my line would keep going on forever and ever. Now, this is a number line that you're used to seeing from middle school. This should look more familiar. Where is it starting? At -4. So your domain starts at -4, and it's going to go on forever and ever to the right side, which is bigger numbers. So x is greater than -4. Now, is it going to have an equal to? This is an open dot, so no equal to. That is your domain. Okay, so now let's do the range. Same thing, but on the y-axis. So let's draw our number line. Where would this number line start? Okay, well, let's see. The bottom would be somewhere on here, and it's an open dot. And then I'm going to squeeze the graph until I can't anymore, right? So I'm coloring and coloring and coloring, and it seems to stop right there because there's no up arrow. But what do we notice? We notice that there's an arrow here. What does that mean? That it's going to keep going. So what does that mean for my number line? That means that I have to keep going to the bottom. Even though you do have this trumps your dot. So you may not have a -4 here, but you have a -4 somewhere over here, so it counts. And you have an arrow, so what does that mean? It means that you're going to keep going and going and going, so you have an arrow. So it starts at 1, so your y value starts at 1, and it's going to go on forever, for infinity. Okay, so what is that? Less or greater? It's going down, and you can see this down arrow, right? So down is less than. And up here where it started, right, at the 1, both of these are filled in. And it's a solid line, so equal to. So there's your domain and range, example 3. So let's go to example 4. Okay, so here's example 4. Again, think of your Dr. XY. So your domain is left to right. So if you were to do this, you can, if you see arrows, so that might be a little confusing for some of y'all, but you know that for sure you would have to have a number line that covers all of this middle stuff, right? So now the question is what would happen? Well, if I have an arrow, it's going to keep going. It's going to keep going outward and outward and outward and outward, slowly but surely. So there's an arrow over here on the right side. What about the left side? Same thing. You would keep going and going and going. So arrow. So you see how there's an arrow going to the left and an arrow going to the right? Well, that just means that it's never going to stop. So it's infinity, negative infinity to infinity. So that means all real numbers. Okay, well, what about your range? Okay, so again, we only see arrows going up. So what does that mean? That means that there has to be a starting point. Well, we can see that this W-shaped graph is sitting right on the x-axis, right here. So I'm going to color starting from there, and I'm going to color my number line until I get to the arrows. Well, what do the arrows mean? It means it's going to keep going and going and going. So there's really an arrow that's going to tell me I'm going to color forever. Well, so your range starts right here at the center. So y, and what is the center? 0. And it's going up. What is up? Greater or less? Greater. Now, at here, on these two, the corners of the W where it's sitting at, that's a solid line, right? This entire thing is a solid line. We can see that. And solid means equal to. So your range is y greater than or equal to 0. All real numbers greater than or equal to 0. Okay, last example. Okay, so for this one, so remember, we need to think of our Dr. XY. Okay, Dr. XY. And remember, so we're going to go left, right, for domain. Domain here, again, do you see how this already looks like a number line? So that just makes it even easier on us. So we can see that it's going to the left for forever, right? If I go on ahead and fill it in here. And to the right for forever. So what do we know about that? That means all real numbers. Now, for your range. Now, if you were to squeeze this on here, these arrows are only going to the left and the right. They're not going up and they're not going down. It's not going diagonally in any shape or form. It's going to the left and the right only. So you have this number line on the y-axis sitting on the number 3. It's never going to get bigger than 3 and it's never going to get smaller than 3. So your range only covers this number because it's never going to go up and it's never going to go down. So what does that mean for your range? Your range is only 3, which is why you use the equal symbol, only the equal sign. Okay, so ta-da, that's another way you can do domain and range. Use whichever method you like more and go do your assignment.